Hello, I'm Kathleen. We're going to be talking a lot about food science this week, so that's why I have my handy apron on. We're going to be doing some labs that involve making some yummy chocolate chip cookies, some sugar cookies, apple pies, even ice cream, and even tea. So we're going to be talking a lot about the processes that occur within that, and please stay tuned for some yummy labs. Okay, so we're going to start with our chocolate chip cookie lab. I had a lot of fun doing this lab, and the first batch that you're seeing here is my room temperature butter. I thought it would be easiest to start with the room temperature butter, and then I went on to do the melted butter and then the cold butter, and I'll talk more about the differences in that towards the end of this. But baking the cookies is a set of chemical reactions. When carbon dioxide and water vapor mix, they create bubbles and allow the cookies to rise, which I saw when I baked them. And so rising opens up the space to keep the cookie from being too dense or heavy. And sodium chloride, which is the salt I added within this mixture, slows down the decomposition of the sodium bicarbonate baking soda, keeping the bubbles from getting too large. And if this didn't occur, the cookies would be very weak and flat. So you can see I've already made the wet mixture. I put the butter in, creamed it with sugar, and now I'm adding the dry ingredients a little bit at a time, mixing it together. So just kind of getting that all evenly distributed, because that's very important. And then it's important to note that when they're in the oven, the heat is working on the butter, the egg yolk, and the flour to change the molecular shape and structure of these elements. And the gluten in the flour that I'm putting in to this mixture at this time, right about now, it's really important to remember that the gluten in the flour forms a polymer that works with the albumin protein and the egg white as an emulsifier of the egg yolk to form the dough and support the bubbles. So all this cool science is happening when it's in the oven. Right now we're just kind of mixing it together. But once the cookies are taken out of the oven, the process doesn't stop. It's important to note that the hot water vapor makes the cookies contract, and heat breaks the sucrose, creating simple sugars, which are glucose and fructose, creating the light brown on the outside of the cookies. And with my oven, I cooked it about 9 minutes in the end for each batch, just to double check and make sure it was fully done. I checked the bottoms at about 8 minutes, and they could use a little bit more time, and our oven's a little different than others, so that's what I decided to do. So chemical changes that occurred during the baking of the cookies allowed the cookies to keep their shape. And you can see my giant bowl of chocolate chips I used. So I kind of put the chocolate chips in at the end because I didn't want to crush them, and folded them in. And what I noticed with the different types of, just talking about the mixture or the cookie dough, is that with the room temperature butter is probably the best use, just because it really incorporated well. As you can see here, it becomes a very uniform dough. And the melted butter, it became very soupy almost. The dough was very soupy and very wet. And then with the cold butter, those cookies actually spread out the most compared to the others, which I thought was really interesting. But the butter probably wasn't fully incorporated, was my theory, because it was so cold I had to chop it up into smaller chunks just to get it mixed in as much as I could. So like the unsalted room temperature butter allowed for an even mix, and the blending of the ingredients together made the cookies more uniform. And it was important not to overmix the eggs here. I really tried not to do that, and mix the flour in a little bit at a time. And when I cooked them, they were all lightly brown. Like I said, I kept the time I cooked them very consistent. I kept pretty much every other condition other than the butter temperature, just because that was my independent variable I was kind of changing around within this experiment. So if I was to do it again, like I said, I would use the room temperature butter, which is what I normally use when I make cookies. Now I just know the reasoning behind it, because it allows it to better mix with the sugar and other things. And it's important to cream your butter and sugar together, especially within this. And when I was making the batch with the cold butter, I had to mix it. I would do everything really fast so I could get it in there and so it wouldn't melt, because I was really worried that it might melt. yeah, so you can see I'm kind of mixing in chocolate chips. And I thought this was a really fun experiment because I was able to really get the why behind making cookies. And it was also important to remember that humidity surrounding the cookies after they're out of the oven impacts them too when they're cooling. I've noticed this especially when I make ginger snaps. If it's very humid or if it's not, it affects how spread out they get. Sometimes they're a little puffier due to all the humidity because they absorb the water vapor. And then other times when I make it and it's not humid, they get really flat. So that's kind of what would have happened if I had changed the humidity as my independent variable. But it's currently raining right now, so if I tried to make cookies right about now, it would be really interesting to see what would happen. But yeah, you can see I'm mixing in the chocolate chips just to make sure they're evenly distributed. And there were a lot of chocolate chips within this recipe, maybe a little more than I would have used. But it allowed each cookie to have a lot of chocolate chips. And it was interesting to see which chocolate chips were meltier based on the butter. Like, I would definitely say that the ones with the unsalted butter melted the fastest. Okay, so we're on to our sugar cookie lab. I just started the video here showing me mixing the eggs, and I put the almond extract into the first batch. And it's really important to note that the butter within this melts at 92 degrees in the oven. It's very interesting to see the butter as an emulsion, whether it was this or doing the chocolate chip cookies, because it was a mixture of two things that don't stay together, and it was a really big impact on both of these experiments. Also, just to note, in this experiment, I was supposed to change one ingredient the second time I made the cookies. So I made 3 batches of chocolate chip cookies, and I made 2 batches of sugar cookies. But for this experiment, I decided to change, keeping everything, the measurements constant. Instead of putting the almond extract in, I decided to put lemon extract in because we had lemon extract, and I thought this would be kind of an interesting take on a sugar cookie. And it made a difference in the taste, surprisingly. Even though it was a very small amount of extract, it turned out really, really yummy. I actually like the lemon ones better. And it's really interesting to see that, like, if dough is chilled versus not being chilled, the shape changes. So I've definitely made cookie dough before where I have to chill it for an hour, and it keeps its shape a lot better if I slice and bake versus another type of warmer dough. And then the fat in the butter coats the gluten, and at 144 degrees, the protein molecules in the egg, once in the oven, uncoil. And the water boils off at 212 degrees, allowing the cookie to dry out. And what's really interesting that was discussed in this lab was the Maillard reaction, which occurs when it's 310 degrees in the oven, and the sugars break down and realign into rings. And what's really interesting is the brown sugar is really the sugar going through this reaction, not necessarily the normal sugar that you'd use in every day, and then caramelization starts occurring when it's 356 degrees, when the sugars break down due to the high heat, which creates the kind of nutty flavor. And I definitely noticed this nutty flavor with the first batch of sugar cookies I made here, because I used the almond extract, which was really interesting. But yeah, I thought it would be the easiest and the most interesting to swap out that ingredient and see what would happen. And as you can see, I kept the butter constant. I kept pretty much everything constant within this. But I decided to change the other, the lemon extract versus the almond extract. And I kept the vanilla extract in just because I thought that was a good constant. You want your sugar cookies to have some vanilla in it. But yeah, you can see here I'm kind of slowly incorporating my flour dry mixture, because I've made the mistake of mixing the dry mixture together with the wet mixture, and that's never turned out good if you do it too early. So yeah, I thought it was interesting how the dough stayed the consistent temperature, because after doing the chocolate chip cookie experiments, this was definitely different. And I thought it was funny that all the labs instructed us to share the cookies, because I've shared them with all my neighbors, with family, friends, and I still have so many to go around. So I'm going up to JMU tomorrow and going to bring a lot of cookies up to my friends. But you can see I'm scraping it out. I just wanted to make sure that there was an even distribution of dry ingredients, because you could find that sometimes your flour kind of sinks to the bottom and then you have like a bunch of extra flour that's not evenly distributed in the cookies. So what's also really interesting is that brown sugar, as I've talked about previously, has the glucose and fructose, which creates the Maillard reaction. I thought that this reaction was particularly interesting, and as your oven gets hotter, I didn't realize that all these different things were occurring. Yes, I saw them baking and I've seen them change. I am an avid cookie baker, but this was something completely new to me. So you can see I'm kind of getting that in there. And I didn't include this video, but I scooped them out pretty evenly and smushed them down just to create the shape of a round cookie. So these were my favorites by far of everything I baked in this lab. Okay, so now we're on to the apple pie lab, where I made both a pie crust and an apple pie with a lot of apples. So baking an apple pie is a set of chemical reactions. Yes, I probably knew this before the lab, but it really didn't sink in until I was doing this lab. And understanding the food chemistry definitely helped me kind of hone my technique. We usually don't make our own pie crusts, which we always thought it took a lot of effort, so I usually just bought the store-bought like Food Lion pie crust. But in this case, I decided to make 2 apple pie crusts, one using water and the other using vodka, which I thought was kind of a bizarre ingredient to choose, but it actually was really interesting. So there are 3 things that make up a pie crust, and they're flour, water, and a fat of some sort. And some recipes call for sugar or salt. And at the basis of all this, the flour combines with the water to activate the gluten inside. And the gluten gives dough its stretch and strength. I've been watching a lot of Great British Bake Off, so I've seen the bakers actually test the gluten, holding it up to a window to see if they can see if it's spread out. So I didn't do that in this case, but I think it's really interesting that one of my favorite shows is also looking into food science. So yeah, so too much gluten in your pie crust will make it like tough and leathery, and too little, you'll have really weak dough that like loses its shape when it's baked, and I've accidentally done this a few times. But you have to make sure it's really balanced, and it's actually in the fat of the pie crust where you get that flaky texture. Like everybody raves about how a good pie crust is so flaky. Well, that's what is wanted here. So as you can see here, I'm just mixing the dough together and trying to get it together. So I've already used the food processor, and I'm just about to get my chilled water from the fridge. And temperature is also an important factor when making a good pie crust. You don't want your pie dough to be really warm, because just like if it was as warm as the cookie dough with the melted butter, that would have been a big problem. So they always require like the chilling period with a pie crust. I've done this a lot with cookie dough in the past, but never really with a pie crust. So it's kind of a pain, because you want to be done, but also it's important. So the ideal temperature is usually around room temperature, but before you roll out your dough, which you'll see me do later, it's important to have it a little cooler, just so it feels like a stick of butter almost, because it's a lot easier to maneuver and put on in the dish when you're doing this. So it's also important. I ended up adding, as you can see, I'm rolling it out. I ended up adding some flour to this just because it was a little sticky even after I'd chilled it. So it's really important to do that. And you don't want your the fat agent, which I put butter and shortening in here, to be too cold or too warm. The temperature is obviously key. And I also made sure my kitchen wasn't too hot because of the oven. So butter melts at a lower temperature than shortening or lard, but it's also very difficult to work with. So it's really interesting to see how that impacted this. I also used shortening. I'm a very big fan of using Crisco just because a lot of my cookie recipes call for that. So you can see here's my apple mixture that I'm sticking in here. And I did this for both pies, pretty straightforward. Peeled my apples, cut them, put my mixture in. As you can see, there's a little bit of liquid, but I tried my best to drain with a slotted spoon, and it was a very tall pie. It took a little while to cook because it was so tall and so full of apples, but I used Granny Smith apples, and it's really interesting to see within the pie crust how the flour coats the pockets of pure fat. There's like a third element that's occurring, but it's kind of being ignored. That's this. And here you can see I'm just mixing it all up, just making sure my dough is good. So, and then here I made an egg wash of the egg white. I usually just use a regular egg when I'm making a pie, but I covered both pies, and I carved a W into the pie with the water and a V into the pie with the vodka because I wanted to be able to tell the difference, and that actually was very helpful. So you can see I'm brushing it onto the water pie, and I stuck them in at the oven, same temperature, pretty much same conditions other than different pie crust. Everything else was kept constant because that was my independent variable. And it was just really interesting to see what happened with my homemade pie crust. And there I am just brushing it, making sure it's fully covered. It's really important to make sure it's fully covered with the egg wash. So I just did all the edges and made sure it was good. And then here you can see there's my vodka pie versus my water pie, and the vodka crust was actually a lot flakier, and it was a lot better than the others. So now we're on to ice cream, which was very fun but very time consuming. So ice cream involves a lot of chemical concepts that I was interested to see. So here I am just using, I used ice, and I made my little mixture as the lab told me to do. And then I put the regular iodized salt in there. That's what I started with. So ice cream is an emulsion. It's a combination of two liquids that don't normally mix together. And one of the liquids is dispersed throughout the other. So ice cream has liquid particles of fat called fat globules, which are spread throughout the mixture of the water, sugar, and ice along with the bubbles. And there's a really good diagram within the lab I encourage you to look at that kind of explains this in a better way. And if you look at ice cream closely, you can see the structure's kind of porous. So yeah, it was really interesting doing this lab because I timed the lab as I was going through it, and the first one with the iodized salt, after watching the videos we had to watch, that one seemed like the thickest kind of ice cream. Like, I would compare each type to no salt was very soupy. It was literally just like cold cream that was vanilla flavored, and then the iodized or the rock salt you'll see me use later, that was very like a soft serve texture, and then the iodized salt made like the creamiest, like the best of the best in my opinion. I don't know why, but I also shook it for a very long time and my arms were really tired, so I didn't really realize how much science really went into creating the ice cream, but it's really interesting to see that with the emulsifiers and the stabilizers, the creamy texture that came out of it. And it's really important to note that stabilizers have two roles. First, they prevent the large crystals formation, and in the presence of like stabilizers, ice cream contains the small ice crystals that are easier to disperse and melt more slowly than the larger ice crystals. And also emulsifiers act like a sponge, kind of absorbing and locking into place any liquid in the ice cream. So common stabilizers are proteins like gelatin and egg whites, which we can find around the house. So it's really interesting to see that once you get your ingredients together to create the ice cream, you need to freeze the mixture. So that's kind of what's occurring within my shaking of the ice cream. And I also checked, you can see it's kind of together. I checked the ice cream every so often, just while I had my timer on, just to make sure that it was becoming solid. And the dissolved solutes, are mostly the sugar in the liquid of the mixture, lower its freezing point, which was really interesting to me. And the freezing point depression of 1.86 degrees Celsius occurs for every mole of solute added to 1 kilogram of water. So otherwise, like if you dissolve 1 mole of sugar in 1 kilogram of water, water
will no longer freeze at 0 degrees Celsius, but rather at negative 1.86 degrees Celsius. So the freezing point depression is colligative property, which means that effect is observed regardless of a specific identity of solute. All that matters is that many molecules are dissolved, and you can see I'm kind of double checking here just to make sure it's done. It was very thick and very interesting to work with, so there I am completing that. So I also tried it with, like I said, just no salt, and here I am using the rock salt just to see if it will make a difference, and definitely mixing that in there. And like I said, the texture of the ice cream that was the rock salt mixture was a lot more soft serve than the previous one. Okay, so now we're on to one of the fun pieces of this lab, which was the tea lab. And I'm not much of a tea drinker. I have a lot of friends that are, so this was pretty fun to make because they like tea. And tea contains a wide variety of chemical compounds, but some of the most important in terms of taste and coloration are the polyphenols. I think I said that correctly. So there's different types of tea, and the polyphenols in black tea contain or can be split into a wide range of categories. And within this lab, I used honey, lemon, ginger, which was pretty difficult to grate, and cinnamon to make my tea. And I also had 3.5 cups of boiling water on the stove. So you can see I'm mixing my mixture together before I put the boiling water in. And what's really interesting is the tea polyphenols have been reported in various research to exhibit antioxidant properties. So antioxidants have been described as having a variety of health benefits, like blueberries have antioxidants, other things like that. But the scientific evidence for these is still kind of vague, as some say. But some studies have shown that antioxidants can protect the cells from damage, from free radicals, and which are molecules with unpaired electrons, which kind of there I am kind of consulting and reading a little more about the black tea. It's really interesting if you can take a look at the lab printout. There's a really interesting diagram that lays out the different tea formations. So there's a wide range of categories of the polyphenols in the black tea. There can be categorized as theoflavins, while therobegens, I'm probably pronouncing this wrong, are a large group of polymeric polyphenols, which specific structures are largely unknown at this point. But you can see I'm just making sure my mixture's really well mixed there. And now you can see I'm dumping the boiling water very carefully into the mixture for the tea, and I had to let it steep for 5 minutes, so I covered it the best I could, and I made sure to really stir it and try to get the honey dissolved. It was kind of hard just to tell because you are using boiling water, but we shared it, my family and I, and noticed that the ginger was the very dominant flavor overall, and I did use a strainer to try to get everything out in the end.
So we learned a lot about food science this week. There's a lot of intricate processes that we don't really think about when we're baking, but it could make the end result better, as you've learned. So thank you for sticking with me through the many, many batches of both chocolate chip cookies and sugar cookies and pies that had different crusts, and tea that was very delicious, and even ice cream that gave me a brain freeze. So I'm gonna go eat some cookies now. So thank you for sticking with me.